A comprehensive overview of some of the world's most powerful cranes. Terex Demag CC 8800, Thialf, Sleipnir, Hyundai 10,000, Zhenhua 30, and Saipem 7,000. In the world of heavy lifting and engineering marvels, cranes hold a significant position due to their ability to handle enormous loads that would otherwise be impossible to move. Among the most powerful cranes in existence are the Terex Demag CC 8800, Thialf, Sleipnir, Hyundai 10,000, Zhenhua 30, and Saipem 7,000. These machines represent the pinnacle of engineering excellence, designed to perform complex lifting operations in some of the harshest environments on Earth. Each crane brings its unique capabilities and specializations to the table, making them indispensable assets in industries such as construction, oil and gas, shipbuilding, and offshore wind energy. Terex Demag CC 8800. The Terex Demag CC 8800 is one of the most formidable crawler cranes in the world, known for its enormous lifting capacity and versatility. Introduced in the early 2000s, the CC 8800 quickly established itself as a benchmark in the heavy lift industry. This crane boasts a maximum lifting capacity of 1,600 metric tons, which can be further enhanced to 3,200 metric tons with the addition of the twin configuration. The crane's maximum load moment, a critical factor in its lifting power, is an impressive 26,160 ton-meters. One of the defining features of the CC 8800 is its modular design, which allows it to be transported and assembled on-site with relative ease, despite its massive size. The crane's lattice boom can reach heights of up to 216 meters when fully extended, making it suitable for a wide range of applications, from erecting wind turbines to lifting heavy components in petrochemical plants. The CC 8800's ability to operate in confined spaces and on uneven terrain further adds to its versatility. The CC 8800 has been involved in some of the most challenging lifting projects around the globe. For example, it has played a crucial role in the construction of offshore wind farms, where its ability to lift heavy turbine components with precision is invaluable. Additionally, the crane has been used in the oil and gas industry for the installation of large modules on offshore platforms, demonstrating its reliability and efficiency in demanding environments. The Thialf is a semi-submersible crane vessel, SSCV, owned by Hyundai Marine Contractors, and it holds the distinction of being one of the largest crane vessels in the world. Built in 1985 by Mitsui Engineering and Shipbuilding in Japan, Thialf has been a cornerstone of the offshore construction industry for decades. The vessel is equipped with two cranes, each with a lifting capacity of 7,100 metric tons, giving it a combined lifting capacity of 14,200 metric tons. The vessel's dual cranes are mounted on rotating platforms, allowing for unparalleled flexibility and precision during lifting operations. Thialf's cranes can work in tandem or independently, depending on the requirements of the project. This capability makes Thialf ideal for heavy lifting tasks in the oil and gas industry, such as installing topsides, jackets, and other large structures on offshore platforms. Thialf's stability in rough seas is another critical factor in its success. The vessel is designed to operate in harsh marine environments, and its semi-submersible design ensures that it remains stable even in challenging conditions. This stability is achieved through the use of ballast tanks that can be adjusted to maintain the vessel's equilibrium, allowing for safe and efficient lifting operations. Over the years, Thialf has been involved in numerous high-profile projects, including the installation of the world's heaviest single-piece topside for the Johan Sverdrup field in the North Sea. The vessel's ability to lift and install massive structures with precision and safety has made it an invaluable asset in the offshore construction industry. Sleipnir. Sleipnir, named after the mythical eight-legged horse of Norse mythology, is the world's largest crane vessel, owned by Heerema Marine Contractors. Built by Sembcorp Marine in Singapore and delivered in 2019, Sleipnir represents the latest in crane vessel technology. It is equipped with 2 cranes, each with a staggering lifting capacity of 10,000 metric tons, giving it a combined capacity of 20,000 metric tons. Sleipnir's cranes are the largest of their kind, and they are capable of lifting loads that no other vessel in the world can handle. The vessel is also notable for its environmentally friendly design, being the first crane vessel to be powered by liquefied natural gas, LNG. This reduces its emissions significantly, making it one of the greenest heavy lift vessels in operation. The vessel's cranes are mounted on a rotating platform, similar to Thialf, allowing for precise and flexible lifting operations. Sleipnir is also designed to operate in deep waters, with a draft of 12 meters, making it suitable for a wide range of offshore projects. The vessel's stability is enhanced by its 8 pontoons, which provide a stable platform for lifting operations even in rough seas. Since its introduction, Sleipnir has set several records in the offshore construction industry. In 2019, it performed the world's heaviest single lift by installing the 15,300-ton topside for the Leviathan gas field in the eastern Mediterranean. This operation demonstrated Sleipnir's unmatched lifting capabilities and its importance in the future of offshore construction. Hyundai 10,000. The Hyundai 10,000, also known as HLV 10,000, is a heavy lift vessel designed and built by Hyundai Heavy Industries in South Korea. This vessel is one of the most powerful in the world, with a lifting capacity of 10,000 metric tons. The Hyundai 10,000 was developed to meet the growing demand for ultra-heavy lifting capabilities in the offshore oil and gas industry, particularly in the installation of large offshore platforms and modules. The Hyundai 10,000 is equipped with a single main crane that has a maximum lifting capacity of 10,000 metric tons, making it one of the most powerful cranes in existence. The crane is mounted on a rotating platform, allowing for 360-degree operation, which is crucial for positioning heavy loads with precision. The vessel is also equipped with advanced dynamic positioning systems, ensuring that it remains stable and accurately positioned during lifting operations. The Hyundai 10,000 has been involved in several significant projects since its introduction. One of the most notable is its work in the installation of topsides and other large modules on offshore platforms in the South China Sea. The vessel's ability to lift and transport extremely heavy loads has made it a critical asset in the construction of offshore infrastructure, particularly in regions where the installation of large and complex structures is required. In addition to its lifting capabilities, the Hyundai 10,000 is designed for long-distance transport, allowing it to deliver heavy components to remote locations around the world. This versatility makes it an invaluable asset not only for the offshore oil and gas industry, but also for large-scale infrastructure projects that require the movement of extremely heavy and oversized components. Zhenhua 30. The Zhenhua 30 is a heavy lift vessel owned and operated by Shanghai Zhenhua Heavy Industries Company (ZPMC), one of the world's leading manufacturers of cranes and heavy machinery. The vessel is part of ZPMC's extensive fleet of heavy lift ships, which are primarily used for the transportation and installation of large port cranes, offshore wind turbines, and other oversized equipment. The Zhenhua 30 is equipped with a massive crane that has a lifting capacity of 12,000 metric tons, making it one of the most powerful heavy lift vessels in the world. The crane is designed for precision lifting operations, with a rotating platform that allows for flexible and accurate positioning of loads. The vessel's large deck space also allows it to transport multiple components at once, making it highly efficient for large-scale projects. One of the key applications of the Zhenhua 30 is in the installation of offshore wind turbines. As the demand for renewable energy grows, the need for heavy lift vessels capable of installing large wind turbine components has increased. The Zhenhua 30 has been involved in several offshore wind projects, particularly in China, where it has played a crucial role in the rapid expansion of the country's offshore wind capacity. In addition to its work in the offshore wind sector, the Zhenhua 30 is also used for the transportation and installation of large port cranes and other heavy equipment. The vessel's ability to handle extremely heavy loads with precision makes it an essential tool for large infrastructure projects around the world. Saipem 7000. The Saipem 7000 is one of the most iconic crane vessels in the world, known for its immense lifting capacity and versatility. Owned by the Italian oilfield services company Saipem, the vessel was built in the late 1980s by Fincantieri in Italy. The Saipem 7000 is equipped with two cranes, each with a lifting capacity of 7,000 metric tons. giving it a combined capacity of 14,000 metric tons. One of the most notable features of the Saipem 7000 is its ability to perform both lifting and pipelaying operations, making it one of the most versatile vessels in the offshore construction industry. The vessel is equipped with a dynamic positioning system that allows it to remain stable and accurately positioned during complex operations, even in deep waters. The Saipem 7000 has been involved in some of the most challenging offshore construction projects in the world. One of its most famous operations was the installation of the Snor-A tension leg platform in the North Sea, where it performed a record-breaking lift of 12,150 metric tons. The vessel has also been involved in numerous pipelaying projects, including the construction of the Aasta Hansteen offshore platform, an engineering marvel in the Norwegian Sea. The Aasta Hansteen offshore platform is one of the most ambitious and technically challenging projects ever undertaken in the oil and gas industry. Located in the deep waters of the Norwegian Sea, approximately 300 kilometers west of Bodø, Norway, the platform stands as a testament to the ingenuity and determination of the engineers and workers who brought it to life. Named after the 19th century Norwegian painter, writer, and feminist Aasta Hansteen, the platform is a centerpiece in the development of the Aasta Hansteen gas field, which is operated by Equinor, formerly Statoil. The platform's construction required overcoming a series of unprecedented challenges, including deep water conditions, harsh weather, and the need for cutting-edge technology. The Aasta Hansteen field is situated in waters with a depth of about 1,300 meters, making it one of the deepest offshore developments on the Norwegian continental shelf. Developing such a field necessitated the creation of a platform that could not only withstand the extreme conditions of the Norwegian Sea, but also operate efficiently and safely in such an environment. To meet these demands, Equinor and its partners embarked on designing a spar platform, a type of floating platform that is ideal for deep water operations. The spar design was chosen because of its stability, which is achieved by anchoring the platform to the seabed with mooring lines, and using a weighted vertical cylinder that extends deep below the water's surface. The construction of the Aasta Hansteen platform began with the fabrication of its various components at different locations around the world. The spar hull, the most critical part of the platform, was constructed at Hyundai Heavy Industries Yard in Ulsan, South Korea. The hull, which measures 198 meters in length and weighs 46,000 metric tons, is one of the largest ever built. The scale of the hull required Hyundai Heavy Industries to employ some of the most advanced construction techniques and tools available. Once completed, the spar hull was transported to Norway, a journey of over 14,000 nautical miles, demonstrating the logistical challenges involved in such a large-scale project. Simultaneously, the top side of the platform, which houses the drilling, processing, and accommodation facilities, was constructed at the Kværner Stord in Norway. The topside is a massive structure in its own right, weighing around 24,000 metric tons. It is designed to process the gas extracted from the field before it is transported via pipelines to the Nyhamna gas processing plant on the Norwegian mainland. The construction of the topside required meticulous planning and coordination, as it needed to integrate seamlessly with the spar hull. Once the two components were combined, the integration of the spar hull and the topside was one of the most critical phases of the Aasta Hansteen project. This operation, known as the mating process, took place in Stord, Norway, and involved lifting the topside onto the hull with extreme precision. The operation required the use of one of the world's largest heavy lift vessels, the Saipem 7000, which is capable of lifting thousands of tons. The topside was carefully aligned and secured to the hull, ensuring that all connections and systems were properly integrated. The successful completion of this process was a significant milestone in the construction of the Aasta Hansteen platform. Following the integration of the hull and topside, the platform was towed to its final location in the Norwegian Sea. The journey from Stord to the Aasta Hansteen field covered a distance of approximately 500 kilometers and took several days. The towing operation required extensive planning and coordination, as the platform had to navigate through some of the harshest marine environments in the world. The stability of the spar design was crucial during this phase, ensuring that the platform remained upright and secure throughout the journey. Once at the field, the Aasta Hansteen platform was anchored to the seabed using a series of mooring lines, each several kilometers long and weighing hundreds of tons. The mooring system was designed to keep the platform in position despite the strong currents and high winds typical of the Norwegian Sea. Installing the mooring lines required the use of specialized anchor handling vessels and remotely operated vehicles, ROVs, that could operate at depths of over 1,000 meters. The precision and accuracy required to secure the platform in such deep water underscored the technical challenges of the project. With the platform securely anchored, the final phase of construction involved the connection of the subsea infrastructure to the platform. This included the installation of pipelines and risers that would transport the gas from the subsea wells to the processing facilities on the platform. The subsea infrastructure was installed by a fleet of specialized vessels equipped with advanced technology to operate in deepwater conditions. The connection of these systems was critical to the successful operation of the platform, as any failure could result in significant delays or safety issues. The movement of the largest railway bridge in the world, a feat of engineering precision. The transportation of the world's largest railway bridge in a single piece stands as a remarkable achievement in the field of heavy engineering. This massive structure, with dimensions of 255 meters in length, 17 meters in width, and 55 meters in height above the ground, and weighing an astounding 8,400 tons, required meticulous planning, cutting-edge technology, and flawless execution to ensure its safe and successful relocation. The bridge, an engineering marvel in its own right, was designed to span significant distances while accommodating the stresses and loads associated with modern railway systems. Moving such a colossal structure in one piece posed unprecedented challenges, requiring not only the strength and capacity of the machinery involved, but also the precision of the coordination and planning processes. The responsibility for this monumental task was entrusted to Cerens, a global leader in heavy lifting and engineered transport. Cerens is renowned for its expertise in handling the most complex and large-scale lifting and transportation projects worldwide. For this project, Cerens deployed an array of self-propelled modular transporters, SPMTs, from Kamag, a company recognized for its innovative and robust transportation solutions. SPMTs are modular vehicles specifically designed to move heavy loads, and they have become indispensable in the field of heavy transport. In this particular operation, Cerens utilized a total of 244 axle lines of Kamag SPMTs with 976 tires to support and move the bridge. The use of SPMTs was crucial because of their ability to distribute the enormous weight of the bridge evenly across multiple axles, ensuring that the structure remained stable throughout the movement. Each axle line of the SPMTs is designed to bear substantial loads, and when combined, they can transport objects weighing thousands of tons with precision and control. The movement of the bridge required the SPMTs to be positioned strategically at each end of the structure. This positioning was essential to maintain balance and ensure that the bridge could be lifted and transported without any risk of structural damage. The SPMTs were carefully synchronized to work in unison, allowing for the gradual and controlled elevation of the bridge from its original position. This synchronization was critical, as even the slightest misalignment could have led to catastrophic consequences, given the immense weight and size of the bridge. Once the bridge was elevated, the SPMTs began the slow and deliberate process of transporting it to its new location. The entire operation was conducted with painstaking precision, with the SPMTs moving at a very slow pace to avoid any sudden jolts or shifts that could destabilize the load. The transport route was carefully planned and prepared in advance, with ground reinforcement and other necessary modifications made to ensure that the SPMTs could navigate the terrain without issues. Throughout the movement, engineers and operators closely monitored the SPMTs and the bridge, using advanced sensors and control systems to track the load distribution, alignment, and stability in real time. This constant monitoring was vital to detect any potential problems early and make the necessary adjustments to ensure the safety of the operation. Communication between the various teams involved was also critical, as any miscommunication could have led to delays or errors that might compromise the integrity of the bridge or the safety of the personnel. The successful transportation of the bridge was not only a testament to the capabilities of modern engineering and technology, but also to the skill and expertise of the teams involved. The operation required a deep understanding of the physical properties of the bridge, the mechanical capabilities of the SPMTs, and the environmental conditions that could impact the move. It also demanded rigorous planning, coordination, and execution with no margin for error. Once the bridge reached its destination, the SPMTs were carefully maneuvered to lower the structure into place. This final stage of the operation was just as critical as the initial lift, requiring the same level of precision and control. The bridge was gradually lowered onto its supports, with engineers continuously monitoring the process to ensure that the structure settled correctly and that no undue stresses were placed on any part of the bridge. The completion of this project marked a significant milestone in the field of heavy transport and infrastructure development. Moving a structure of this size and weight in one piece is a rare and extraordinary achievement, one that showcases the advancements in engineering technology and the expertise required to undertake such complex operations. The use of 244 axle lines of KAMAG SPMTs by Cerens demonstrated the sheer power and versatility of these modular transporters, as well as their essential role in modern heavy lifting and transportation projects. In conclusion, the movement of the world's largest railway bridge in one piece